Hello everyone, so welcome back to my channel. So for this video, I'm going to show you one exercise related to how the a value affect the function. So I'll show you the original function here, and I'm going to investigate how these constants here will affect this function. So in the first example, we have y equals 1 over 3 times f of x. So how this 1 over 3 will affect the original function? So let's go back and see what happens. So remember I showed you this slide before in the last lecture. So when a equals to 1 over 3, it falls into this range between 0 and 1. So when a value is between 0 and 1, the vertical portion of the function is contracted by a factor of a. So what does this sentence mean? So it means that the y component, the vertical component, will be contracted by this factor, by a. So basically when the a value is 1 over 3, I need to times 1 over 3 for every y values in the original function, but the x coordinate remain unchanged because I'm only focused on the vertical movement. So your first step always need to draw the table value looks something like this, and x and y. We have x and y column. So when x equals to -8, the y equals to -3. When -3x, y equals to -3. So far, so forth, 3 and 3, and 8 and 3. So I want to investigate how the 1 over 3 affect original function. So remember, the 1 over 3 here will only affect the vertical movement of this function. So that's why I need to times 1 over 3 for each of these y coordinate. So, and these y coordinate will become smaller, so which means that the vertical component becomes smaller and the function becomes contracted in the vertical direction. So if I multiply 1 over 3 for every y value, this is the new y coordinate I could got for the first function, y equals 1 over 3 f of x. So we have -1, -1, 1, and 1. So this is my new y coordinate. So I don't change the x coordinate when we are dealing with the a factor's value. So next I'm using this information to plot the function y equals 1 over 3 f of x. So this is my x coordinate, and this is my new y coordinate. So let's plot this. So the first point we have -8 and -1. So approximately at this position, right? So what about -3, -1? So approximately at this location right here. And also we have 3, 1 at this location and 8, 1 at this location. So I'm going to connect this point. This is what the shape what you could get for this function y equals 1 over 3 f of x. So next I want you guys to try this question, number 2, y equals 2 f of x. So please make sure you try this out before you proceed. So please pause the video now and try this out. So I hope you guys all have chances of doing these questions. So let's go over this. So we have y equals 2 times f of x for my second equation. So what is the 2? How the 2 here will affect the original function? So when the a value equals to 2, right, is fall into this range. When a greater than 1, the vertical portion of the function is expanded by the factor of a. So which means that the vertical component is greater when the a value is greater than 1. So when a value equals to 2, the vertical component of the function is expanded by 2. So which means that I need to times all the y values in the original function by 2. So let's do this. So if you multiply by 2 for every y value, I could get -6, -6, 6, and 6 respectively. So these new y coordinate belongs to this function, y equals 2 times f of x. And I will use these two columns here to graph the function y equals 2 times f of x. So let's do this together. So -8 and -6 is around at this position. So -8, -6 around this position. So -3, -6 around this position. 3 and 6 around this position. And 8 and 6 around this position. So it's a really big graph. It's a really huge graph in the y direction. So let's graph this. So if you connect these points together, you could get this shape from here to here, right? So this is a new function, y equals 2 times f of x.